Okay, this lesson's on solving equations using logarithms. There's three scenarios I'm going to go over here, starting with easy and then working to a little bit more harder. The first one is just you have a simple exponential equation you need to solve for the exponent. I'm going to start off by putting logarithms on both sides. What you do to one side, you need to do to the other. So I have log 3x equals log 11. I want to bring my exponent using one of the logarithm rules down and put it in front. So x log 3 equals log 11. I'm going to divide by log 3 to get the x by itself. Log 11 divided by log 3. And now you can simply put that into your calculator. Log 11 divided by log 3. And we'll give you 2.18. Same as this one, but now this one has a natural log. It has e. So that means I'm going to have to use natural logs instead. So natural log e to the x equals natural log 15. Now, with the natural logs, like mentioned in a previous video, if you ever have natural log and e side by side, you can simply just cancel them out. So really, in this case, I don't need to go through all this rearranging. I can just simply get x by itself, because I canceled that out, natural log of 15. If you did do all the rearranging, it would be totally fine. You would get the exact same answer, but you don't need to. Natural log of 15 equals, in this case, 2.71. Okay, so this example right here, scenario 2, now I have a number in front. First thing I want to do is divide that 5 over to the other side. And that'd be 100 divided by 5, which is 20. And now I just did that step and it becomes exactly the same as the previous examples where you're just going to want to put the logarithm on both sides. I know to use just a regular logarithm because it has no e in it. Bring your exponent down front. Divide by the log 4, and you can put it in your calculator and you'll get an answer. Log 20 divided by log 4. Same as in this example. First thing you want to do though, divide that 60 over to the other side. 1005 divided by 60 is 16.75. Now, I want to, this again, it's the exact same. Looks the exact same as the previous example we did. But this time, again, I have an e, so that means I'm going to do the natural log. Natural log. And whenever you have natural log and e side by side, I don't need to go through all that rearranging. I can just simply cancel it out. Now, I don't have x completely by itself. So that means I need to divide by 0.5. Natural log 16.75. On the other side to get the x completed by itself, and now you can put in your calculator. And it gives you an answer of 5.64. Okay. The third example is where you get multiple logarithms. Now what you want to do is get one logarithm on either side. And then you can cancel them out. Okay, so what I want to do, I need to turn this whole number into a logarithm. Now this is log base 2, so that would be the exponent. The exponent 3 on base 2, 2 to exponent 3 is 8. So I have log base 2 of 8 plus another log base 2 of 8 equals log base 2 of x. Adding means to multiply. Log base 2 to get from 2 logarithms down to 1 logarithm. So multiplying is 64. I have one logarithm on either side. They are the same bases. Now I can cancel the logarithms out. So my answer is simply for 64 equals x. Here I have, again, multiple logarithms. Natural log, natural log, natural log. Okay, so the same rules apply. Adding means to multiply. I want to get from 2 logarithms down to 1. Natural log of x times x plus 1 equals natural log of 20. So that's the natural log of x squared, multiply, plus x equals natural log of 20. Cancel my natural logs out because I got down to 1 on either side. rearrange, make it equal to 0. This is a quadratic. Make it equal to 0. And now I can simply factor that. Well, multiplies to negative 20, adds to positive 1 would be 5 and 4. So x equals negative 5, x equals 4. Now, when you got to be careful with these answers, because you got to make sure it's actually going to be possible to, in the question, if the answer doesn't work in the question, it can't exist. So my answer is a negative 5 and 4. If I was to put negative 5 in for these x values, I would get negative, it would be taking the natural log of a negative number. You can't do that. You can't take the natural log of a negative number. If you remember the graph of logarithms, the x's are always positive. So you got to make sure you're taking the logarithm of a positive number. So in this case, this is not going to be possible, but this one is. So your answer is x equals 4. Now, if you could have a negative x here, not be all right, as long as it doesn't mean that up here, what you're taking the natural log of a negative value. So if it's a value that might be x might be negative itself, but not make this go negative, that would be okay. But in this case, there's only one example that works. It's a short example or short question on solving logarithmic equations. There were 3 scenarios we went through.